Good afternoon, dear colleagues and guests. Let me declare open the session of the Dissertation Council for the Defense of Thesis by Abbasov Majid Elkhan for the degree of Doctor of Physics and Mathematics, Specialization 010109, Discrete Mathematics and Mathematical Cybernetics, on the theme Exhausters and Coexhausters in Non-Differentiable Optimization. According to the order of St. Petersburg University of the 26th of April 2019, number 4364/1, myself, Polякova Ludmila Nikolaevna, Doctor of Physics and Mathematics, Professor, Department of Mathematical Theory of Control Systems, modeling at St. Petersburg University, was appointed chairman of this Dissertation Council. Also, let me introduce my fellow council members. Zakharov Viktor Vasilyevich, Doctor of Physics and Mathematics, Professor, Department of Mathematical Modeling of the Energy Systems of St. Petersburg University. Afanasyev Alexander Petrovich, Doctor of Physics and Mathematics, Professor of Kharkiv Institute of Information Transmission Problems of the Russian Academy of Sciences. Bukhanovsky Alexander Valeryevich, Doctor of Technical Sciences, Professor of St. Petersburg National Research University of Information Technologies, Mechanics and Optics. Antipin Anatoly Sergeyevich, Doctor of Physics and Mathematics, leading researcher of the Dornitsyn Computing Center, the Russian Academy of Sciences. And in the remote mode, we have Roshina Vera Alexeyevna, Doctor of Physics and Mathematics, University of New South Wales, Australia. First, let me emphasize that according to the federal law of the 23rd of August 1996, number 127, on science and the state scientific and technical policy, St. Petersburg University has the right to award academic degrees independently. The corresponding order on the procedure for awarding academic degrees at St. Petersburg University, on the basis of which we are holding this session of the Council, was issued on the 1st of September 2016, order number 6821/1. In accordance with this order, the session of the Dissertation Council is duly constituted if at least 2/3 of the approved members of the board of the Council are participating, but not less than 4 persons. Our Council consists of 6 members. All the members are present, including 1 member in the interactive mode. Thus, there is a quorum. Let me set forth the procedure of today's session with a total duration of no more than 2 hours. We shall start with the chairman's summary report on the main contents submitted by the applicant and their compliance with the applicable regulations. Answers to possible questions, 5 minutes. A brief presentation of the degree applicant outlining the key points of his study, 15 minutes. Questions to the applicant strictly on his report, no more than 5 minutes per question. Answers of the applicant. Speeches of all members of the Dissertation Council with their feedback, with statements of their positions, questions and suggestions to the applicant. No more than 10 minutes for each speaker. Speech of the chairman and her review. answers of the applicant to questions and remarks of the members of the Dissertation Council, no more than 15 minutes. The open discussion. Speeches of the attendees with the summary of their positions and or with specific questions and suggestions to the dissertation strictly on the topic of the study, not more than 5 minutes per person. At that, all the speakers are kindly requested to put their names on the registration sheet and introduce themselves in full before speaking. Final answers of the applicant to the questions asked, no more than 5 minutes. One of the items of the meeting should have been the speech of the academic supervisor with his feedback. But, to our great regret, the scientific supervisor of the applicant, Professor Demyanov Vladimir Fyodorovich, has died and will not speak, and his feedback will not be presented. A 5-minute discussion before the open voting on awarding or not awarding the academic degree to the candidate. For the time of this discussion of the board members, the broadcasting shall be suspended. Open individual voting. The chairman shall count the votes and the results shall be recorded in the minutes of the meeting. A decision on awarding or not awarding the academic degree to the applicant and closing remarks of the candidate, no more than 5 minutes. Before starting the official procedure, let me remind you to switch off your mobile phones. Thank you for your understanding. Please give me a second to do this. Let me also inform you that our meeting shall be recorded and broadcast online at the university website, and the speeches are being simultaneously translated from Russian to English or from English into Russian. So, let me start the meeting with the first item, the Chairman's Summary Report. The Thesis by Abbasov Majid Elkhan ogly for the degree of Doctor of Physics and Mathematics, Specialization 010109, Discrete Mathematics and Mathematical Cybernetics, on the theme Exhausters and coexhausters in nondifferentiable optimization, was accepted for defense by the order of the Academic Secretary of St. Petersburg University on the 21st of February 2019, order number 1457/1. The Dissertation Council was appointed by the order of the Academic Secretary of St. Petersburg University on the 26th of April 2019, number 4364/1, and supplemented by order of the 17th of May 2019, order number 5150/1. And I have already introduced its members to you, dear colleagues and guests. The candidate submitted the following documents to the Academic Secretary of St. Petersburg University: an application to the Rector of St. Petersburg University, Professor Kropochev, to accept the thesis for consideration and defense submitted on the 11th of January 2019, a list of 39 publications which set out the main scientific results of the thesis, including 7 articles in peer-reviewed scientific journals from the list approved by the Ministry of Education and Science of the Russian Federation, and 13 publications in journals indexed in the Web of Science and Scopus Science databases. A diploma of Candidate of Physics and Mathematics with Specialization 010109, Discrete Mathematics and Mathematical Cybernetics, DKN number 154325, the 3rd of April 2012, number 74 NK2. And the thesis in Russian and English on paper, on the rights of manuscript, and in the electronic form. The thesis has been formatted in accordance with requirements of GOST R7.0, printed on a multiplier with the indication of the output data, according to GOST R7.0.4. It should be noted that all the above documents listed above comply with Clause 12, Section 3, Thesis, Presentation and Defense, of the procedure for awarding the academic degrees at St. Petersburg University. Annex to the order. So this is the list of documents submitted by the candidate. Now, next point on our agenda is the applicant's candidate summary report. Good afternoon. I will talk about the main results of my work, and I will try to comply with the recommended time frame. We will work with functions that can be differentiated by direction. Here are the definitions of Dini and Adamara's derivatives. The class of such functions contains smooth and many non-smooth functions. If at the point x the minimum function x is reached, the derivative in the function in this point in any direction is not negative. I use these conditions and the representations of the derivative in the direction, the smooth case, to get the necessary condition the gradient is equal to 0. In order to obtain similar constructive conditions in a rough case, we need a rough representation for derivative in the direction. One of the most successful attempts on this part are quasi-differentials. In terms of these objects, Ludmila Palekova described the conditions for the extreme, developed the technique of searching for the directions of the fastest descent and ascent. However, it was natural to expand the class of functions under study. That's how exhausters appeared. Any quasi-differentiated functions has exhausters, and the opposite is, in general, is wrong. Pshenichin introduced the definition of the upper convex approximation. Here we can assume that H. Further, the notion of exhaustive family approximation was introduced in the works of Demyanov and Rubinov. Rubinov proved the theorem of the existence of exhaustive family of approximations. Then Demyanov introduced the notion of the upper and lower exhausters. In case of the Lipschitzian function, we come to the representations presented on this slide. The up and low exhausters are a familiar convex compacts allowing to represent the derivative in the direction as a minimax or maximin in the linear functions respectively. The minimum conditions are most organically expressed with the help of the upper exhauster. Therefore, the upper exhauster is called proper for the task of this minimum. The necessary conditions that can be contained. So in the smooth case, the upper exhauster consists of one set, the only element of which is the gradient. So we may say that the unit of exhausters summarizes the results of the smooth case. If the requirement is not met, one can find the direction of the fastest descent. To do this, one needs to find the most distant from 0 set in the family, and then the element of this set where the minimum distance to 0 is reached indicates the direction of the fastest descent. In our paper, we show that the search for the direction with the help of the in fact, the search for the direction by the upper exhauster constructed with the help of quasi-differential. However, such construction leads to the growth of the exhauster, which increases the computational costs of implementing optimization algorithms. Let's consider functions. which has minimax upper exhaustive. It includes 5 sets. And the direction of fastest descent is determined by determined by set C2. However, when constructing this direction with the help of quasi-differential, in fact, first the upper exhauster is seen with quasi-differential as well. Thus, it turns out that even the same direction for fastest descent, yet instead of working with 4 single point sets, we work the 4 squares. Thus, it turns out that even for quasi-differential, it's better to use the concept of exhauster rather than of quasi-differential. And in case of families of convex compacts providing, if in case of families of convex compacts providing inf sub and sub-inf representations of the derivative in the direction, we obtain the definition of generalized exhausters. In paper, the paper proves the theorem of existence of aggregated exhausters, which is of constructive nature. Here it's stated that the upper aggregated exhauster can be obtained as a family of open half spaces. The theorem for aggregated lower spaces formulated in a similar way. As noted above, the minimum conditions for most organically expressed in terms of the upper exhauster, so it was called proper for the task of the minimum. Correspondingly, the low exhauster for the same problem, the low exhauster of the same problem, whereas in this paper we obtained conditions for the extremum in terms of proper and improper aggregated exhausters. Any epsilon bands non-strictly separates 2 sets of aggregated low exhausters. Let's consider a function that's equal to function f at x, which is x of 0, where the argument includes all rational numbers and normalized argument are rational numbers equal to the besides is defined as 0. It's not. However, function is differentiable in the direction in the sense of Dini, and with the help of the theorem of existence of aggregate exhaustor, it's possible to construct aggregate exhaustor for this derivative. You may say is not Lipschitzian, so it's not quasi-differentiated. But it is possible to construct an aggregated exhauster, and with the help of here you may see the aggregated up and low exhausters, and we find that the conditions requirements are met. Since if we try to check the maximum, if the maximum requirements are not met, and it's the descent for the fastest ascent. Since the first this task was the problem was first considered by Vera Roshina. She introduced the definition of the minimum conditions by inclusion. The exhauster of the positively homogeneous function H is called the minimum one by inclusion if none of its family sets can be discarded. None of the sets can be discarded. This definition refers only to the number of sets in the family, but it doesn't take into account the structure of the sets themselves. For example, for the X module function, the E2 family is the minimum one included in the upper exhauster. At the same time, there's a smaller exhauster, E1, E2, which is a family consists one segment, which is an intersection of segments including E2, and this exhauster obviously is smaller than E1. Therefore, another definition of the minimality of exhausters was given. A minimality by form. Exhauster is a positively homogeneous function. H is called minimal in the form if there is no other exhauster with the same function, each set of which is included in one of the sets of the original exhauster. From the minimality of form follows the minimality of inclusion. To formulate geometric additions of minimality obtained in the work, as well as the technique of family reduction, we need the concepts of reference hyperplane and the resulting half space. We need the concepts of reference hyperplane and the resulting half space. Isolated half space generated by this hyperplane. Here's the first result. Here we present a theorem that allows us to check the minimality of exhausters by inclusion, as well as to reduce them if this condition. That means to discard a set of exhausters is necessary and sufficient that a closed negative half space of any reference hyperplane to this set lay at least one more set of this family. As an example, let's consider the function presented on this slide. Here, the upper exhauster consists of 5 half spaces, and as this illustration shows, the closed half space of any reference hyperplane always includes one of the remaining single-point sets. That means that C1 can be discarded, producing an exhaustive smaller inclusion, shorter. Let's now turn to the results obtained in our work. Several sets of a family often have an intersection, and there's a natural desire to replace all these sets with their intersection. The theorem presented here suggests sufficient conditions for such replacement. To illustrate this theorem, the Ash from G function, the upper exhauster here consists of 3 sets. C1, C2 have intersections, and any closed negative half space of any reference hyperplane to the square always contains at least one of the sets forming the intersection. So that means that C1 and C2 can be discarded and replaced by their intersection. So from a long representation, we proceed to a short representation. Also, it's important when exhauster consists of convex polyhedrons, we may want to reduce the family by reducing the number of its sets by discarding some of the vertices in the family. That is, if we discard one point of the convex shells of 3 points, we get a segment instead of a triangle. Here we show the prerequisites for such reduction that we obtained. Here's a sufficient condition which can be illustrated by the following example. Here the upper exhauster includes 4 triangles, and in order to represent this point of C1 set, any reference hyperplane to C1 set, there's always another hyperplane which divides C1 set and another set of the family, which is C3 in our case, so that C1 is in the positive half space dividing this hyperplane. Once we meet this requirement, we can discard this point. Same is true. Although the exhausters allow spending a shorter exhauster depicted in B, shown as 4 segments. That means that function Ash can be recorded in a shorter form. Although the exhausters allowed expanding the class of functions under study, they retained a significant drawback of quasi-differentials. The exhauster representation is discontinuous in the Hausdorff metric. This may lead to problems when using the optimization algorithms that use these objects, and to overcome this problem, we introduced the definition of coexhausters. These are families in space per unit of larger dimension, with the help of which the function increment in the vicinity of one point under study can be approximated in the form of maximin or minimax of affine functions. A class of functions with continuous coexistence can be identified in this paper. We have obtained the conditions of minimality of coexhausters. These results were derived using the same ideas and methods as for the exhausters. Therefore, I will not dwell on them in detail. In terms of coexhausters, the conditions of extremum without restrictions have been described earlier. However, the issue of describing the condition of extremum with the restrictions in terms of these families remained open. This problem was solved in our work. They were obtained as the minimum conditions with the restrictions in terms of upper proper coexhauster, as well as the minimum conditions in terms of the lower improper coexhauster. A new direction in the theory of coexhausters of the second order. These are the families of convex compacts which allow approximating increment of the studied functions in the vicinity of the studied point in the form of maximin or minimax of quadratic functions. Coexhausters of the second order allow to construct a non-smooth algorithm of the second order. We obtain the formulas for calculating coexhausters of the second order. Here we show the theorem that allows to obtain a bi-coexhauster of the second order for the sum of two functions for a product of function by a number. The theorem allows to obtain second order bi-coexhaustor of the production of two functions. Is similar this theorem. Production of two functions. The formulas were cumbersome, so we had to put them on a separate slide. The same result, we got same results for quotient, continuation of obtained formulas. As a result, it allows to obtain the lower coexhaustor of the second order of the maximum function, as well as the second order upper coexhaustor for the minimum function. And in this paper, we consider in detail the case when the upper coexhaustor of the second order consists of one single convex polyhedron. And for this case, we have proposed an optimal algorithm of the second order. The summary of the convergence theorem has been proved. The paper also considers an important auxiliary problem of orthogonal projecting of zero on a set, which arises when solving problems of non-differentiated optimization using exhausters and coexhausters. And we propose several simple heuristic probability algorithms. The idea of the basic algorithm is as follows. Having the next approximation to the solution X, we generate a random point by means of uniform distribution of a sphere with a center in the radius 0. If it belongs to our set, we take it as the next approximation. If not, we continue random generation. If we fail at any point after some large number of generations chosen in advance, we select the obtained point as the solution. Here is that's the idea of the simplest algorithm, a description of this algorithm, dichotomy as well as learning. Using these algorithms, you can. These algorithms can be used to get rough approximation to the solution. If we need to refine it, we can also apply the charged ball method described in our paper. The idea here is that a negatively charged ball is placed in the beginning of the coordinates and fixed, and a positively charged ball is placed on the boundary of the set, which can only move along the boundary in the presence of Coulombic forces and viscous friction. It follows from the laws of mechanics that a positively charged ball seeks the position of equilibrium, which coincides with the solution of our initial problem. Having described the differential equations of motion, we obtain a continuous variant of the algorithm. This algorithm, the convergence theorem, has been proved. With additional assumptions, estimates for the convergence rate have been obtained. Using the Euler method to solve the obtained system of differential equations, we can describe the iterational algorithm for solving the initial problem. Here's only one modification of the algorithm, and our paper shows that this idea can be used for such tasks as the search of the minimum distance between two convex sets and many others. So the idea is universal and can be applied to more complicated problems. the distance between curves in 3D space. That's the end of my presentation. Thank you. Hopefully I was on time. Okay, questions to the applicant? Do we have any questions? Does anyone have questions to the applicant? I have two questions. Do I have to introduce myself? Bukhanovsky Alexander Valeryevich. I have two questions. My first question, in slide 15-16, you used a wonderful concept of exhauster growth and growth. In this slide. Is this can this concept be formally measured? I don't remember if you say that in exhauster. The definition of exhauster is ambiguous. A single set can have several families. And what do we call the smallest exhauster? Further, in my thesis, I introduced the concept of minimality. In form and minimality, minimality of inclusion. So it's necessary to consider the two exhausters, to compare the two exhausters by form or by inclusion. So it's either or there's one single. Do have one single indicator of growth. There's no universal indicator. We need two exhausters, and we need to compare them. And which do you find the small one? And my second question, in the last slides, where you describe the charged ball method, if we talk about clarification, the speed of convergence heuristic algorithm, and well, it's certainly higher in charged ball. So where do we stop the algorithm? Where do they converge? The heuristic methods, the probability methods, have connected with practical implementation. They enable us to get very rough approximations. After a certain point, we cannot use them to refine, to get more refined solution to our problem. So this moment, starting from there, we have to use when this heuristic algorithm can no longer be used to find a solution to the problem. Is there a formal representation that we would say that the growth effect epsilon at 2 step is 2 times bigger when we observe in the charged ball method? In our case, we have the stop criteria, which shows how close we are to the solution. So this stop criteria, if we apply it when we see the situation is not getting better, then we should use the more refined procedure, switch to the more refined procedure, represented than the one represented here, the charged ball method. Thank you. You are using examples. You are given examples. Here's the example. Minimax, all the examples, all functions to which you apply your technique. They are all built according to the same principle. Are there any other methods of constructing these functions? Other different methods of differentiation? So how will be your answer? The function represented here, of course, is a derivative by direction. A derivative by direction here, this derivative by direction, we may describe it as a representation for the derivative of direction, exhausters and quasi-differentials. For exhausters, we developed a calculation formula which can be used for construction of such minimax representations. And in case of non-smooth function, we may try to apply these computation formulas, get a representation of in this minimax form or minimax form. This idea was developed and is being developed by Demyanov school, and the key idea is the constructive non-smooth analysis, where the researcher has an opportunity to construct objects. If we mean exhausters, the same applies to quasi-differentials. And one more question. Do you have any applied examples? I know that you are getting this question all the time. As for the applied application, we don't have any examples of practical application, though our results can be applied to a wide class of non-smooth functions. So researchers, when they come across a non-smooth function, they can use the method. So if someone runs in this problem, then you are lucky. Is that right? Thank you. I also would like a question about the practical side of your work. I know that some students of Professor Demyanov had questions about application of these methods, distribution of cluster problems. Has there been any improvement here? I have not worked on clusterization problems. The methods used in these tasks had non-smooth functionality. The functionality was studied, and in this case, the tools developed enables us non-smooth functionality. Tools can be applied to study non-smooth functionality, and the class of functions with exhausters is wider when the class of quasi-differential functions, and is more flexible. You get more flexibility when solving such tasks, such problems. So these tools can be used to create better functionality. Do you think that clusterization will be more accurate in the past? Yes, we certainly hope. We are hoping for that. More questions? Please tell us such beautiful definition as differential. So it's just so pretty. Exhausters. Exhausters is just something completely different from quasi-differential. An exhauster is used to represent a derivative by direction, and in a smooth case, a derivative by direction is measured through its gradient. So is a production of gradient by direction. if we try to create an exhaustive for a smooth function, we get a family which includes only one single point set, which is the same as the gradient. In a non-smooth case, this family becomes much bigger. It may include a multitude of many sets, even which are not necessarily single point. So we get more families, we get the biggest family, and the task becomes more complicated, which is natural because non-smooth function is more challenging for research. So if we try to determine all the methods developed here for a smooth case, we get a well-known and understandable case for a smooth. If we use the extremum condition, we get gradient equal to 0, and descent at the direction of fastest descent. If we try to measure for the, so then we get a direction of anti-gradient. And convergence can also be described in this respect. Yes, convergence is. Let me. I mentioned one result here. Yes, we may say that convergence, the speed of convergence assessment. We don't have any external reviews. Let's hear the reviews. We didn't get any external feedback. So let me give the floor to Viktor Vasilyevich Zakharov. Thank you. So I shall read my review and make some comments if possible. First, in my feedback, I speak about the relevance of the problem, and it should be noted that in the theory of non-smooth analysis, includes sub-differential, and for working with wider classes of non-smooth functions, which were demonstrated here. And the theory of exhausters and coexhausters is a new direction, as very recent, as a segment of non-smooth analysis, and is developing its key points. Research in this field, results of which are described in this thesis, are definitely relevant and important from the theoretical practical point. Speaking of the main results, first chapter is dedicated to the theory of exhausters, describes conditions of extremum in terms of aggregated exhausters, proves the theorem of existing aggregated exhausters, contains a comparative analysis of applying coexhausters and quasi-differential for solving problems of non-differentiable optimization. Describes new minimality conditions of exhausters and the technique for reducing the families. The above mentioned results have been presented in the following publications of the author. Let me mention an article in 2015, the American Institute of Mathematical Sciences, an article published by American Institute of Mathematical Sciences, an article published in 2013, the Applied Mathematics series, Journal of Optimization Theory and Applications, Springer 2017, and Journal of Global Optimization, also published an article by the applicant in 2018. These are well-respected journals where the author described the results of his research. In Chapter 2, dedicated to the theory of coexhausters, the author describes extremum conditions with limitations in terms of coexhausters, described new terms of minimality of coexhausters, describes commutation of coexhausters of the second order for subclass of function of maximum, develops a method of minimization of the second order. Well, the results of his research were also published in many respected journals, such as the St. Petersburg University Journal, 2019, Applied Mathematics, Reduction and Minimality of Coexhausters, Mathematics, Mechanics, Astronomy, St. Petersburg University Journal, 2018, Computation of Coexhausters of the Second Order, St. Petersburg Journal, Applied Mathematics, Informations and Management Processes, and Second Order Minimization Method, Non-Smooth Functions. It should be noted the first two chapters use results obtained by the author in his earlier publications, 5 of which I would like to mention. Chapter 3 describes the charged balls method, the candidate developed for dealing with supplementary tasks, which has practical applications such as new heuristic mechanism. Among other important publications, like 2017, there's a publication where the author described the charged ball method. It was a joint paper published jointly by Majid Abbasov and Vladimir Bure in 2018. It should be mentioned that the theoretical significance of the thesis lies in construction and development of the key points of the exhausting coexhaustor theory, identification of the extremum conditions. Credibility is verified by the results and logic of this paper, and sufficient number of publications in peer-reviewed journals, and in Web Science and Scopus databases. The credibility is verified by support provided by experts of the Russian Scientific Fund and Russian Fund of Fundamental Research. The results were presented at many significant international and national conferences and seminars. All these the examples demonstrated examples proved in multiple experiments. I have some minor comments which I would like to. When functions f1 and f2, upper coexhaustor for H, and they are upper exhaustor for the function, as well as the low exhaustor of the function, can be obtained with the help of quasi-differentials. My second comment, you could by multiplying the rules of multiplying by coexhaustor by number, as the multiplication of pair of sets over number has already been explained on page 18. And on page 106, to illustrate the advantage of the proposed geometric conditions of exhaustor minimality of the previously developed approaches to solving the problem, the reader is invited to turn to example 174, which is described on page 68. Referring to the material that was 20 pages earlier, complicates the reader's work. This example should have been given directly on page 106. Of course, these comments do not affect the overall positive impression of Majid Abbasov's thesis, which is a valuable study, and the thesis deserves the thesis on the theme exhausting coexhausters in order optimization meets the key requirements set forth by the order of the rector, the 1st of September 2016, on the order of awarding academic degrees in St. Petersburg University, and its author, Abbasov Majid Elkhan, deserves being awarded a degree of Doctor of Physics and Mathematics, Specialization 010109, Discrete Mathematics and Mathematical Cybernetics. Clause 11 of the above-mentioned order has not been violated by the candidate when publishing joint papers. The candidate made his contribution. Thank you. Thank you. Dr. Afanasyev, let's hear your review. I will not read my complete feedback because it's quite similar to the review of by my colleague. Let me make some small comments. Well, first of all, I'd like to comment on high scientific significance when Jan, what's next? What will come next? So what next shall we study? So what's beyond this galaxy that we discovered? And of course, is naturally find subdifferentials, but the question of what's next is always there. And very often it's hard to answer this question, and it gets more and more difficult over the time, but our young colleague found a very good method to answer this question. I think this is a remarkable result because of course we are not only solving difficult problems, but we have to understand. Okay, and as for the formal part, let me read some comments to which I would like you to pay attention. It will be more interesting if you, in your work, how the issue of the developed non-smooth analysis of the functions satisfying the Gelder's condition. More attention should have been paid to the relationship between exhausters and coexhausters and copters, well known to researchers. For example, it was necessary to emphasize the fact that the subdifferentiated function has an upper exhauster consisting of a single set of subdifferential and a low exhauster, which is a family of single point sets containing all the extreme points of subdifferential. And emphasizing these points would make it easier to understand that the tools of non-differentiated optimization studied and developed in the thesis are in line with the general research in this field. The item my last comment is that item 3232 was also worth considering examples with more complex curves and discuss the effects of their curvature on the algorithm performance. Yet, of course, these comments should be taken as comments rather than criticism, and of course the positive impression made by the thesis. Thesis is a success. This is very good work, and well, the thesis of Abbasov Majid Elkhan on the theme exhausted and coexhausted in non-differentiated optimization meets the key requirements set forth by the order number 68/1 21/1 on the order of 1 academic degrees in Petersburg University, and the candidate Abbasov Majid Elkhan deserves to be awarded the degree of Doctor of Physics and Mathematics, Specialization 010109, Discrete Mathematics and Mathematical Cybernetics. Clause 11 of the above-mentioned order has not been violated. Thank you for your attention. Okay. May I give the floor to Alexander Valerievich. I absolutely agree with what was mentioned above. So that's why let me comment not only the scientific and practical side of these three chapters. The first chapter is devoted to the study of exhausters themselves. The very ugly external structure is introducced. Yet one should understand that computational for a computer is easier for a computer to work with these squares rather than create more beautiful structures. So no matter what is being said here, this certainly opens new opportunities for optimization. A second step in the second chapter, coexhausters. So this try to higher order introducing their own and somehow they started computing, but when such non-smooth tasks, what do people do? Take a critical algorithm, and I don't think that makes sense. So this genetic algorithm I use, we all know what's missing there. Isn't the coexhauster logic will make this field more attractive, which is also well important. It's important, if possible, to and finally the third direction is even better because it deals with algorithm of dealing of additional problems, auxiliary problems. So these small tasks can be used to deal with greater tasks, which is the key task of today's optimization. And I think this so the result has great practical significance. But let me also give some of my comments when the author refers to himself, his school, and his colleagues from Belarus. I think well, it's over the 100 quotations. But if we talk about how are we practical researchers, how do we choose a good approach which is used in the United States? So it would be good to know how your approach is better. My second comment is metrology, computer metrology. There are many tables. For example, page 231 is a very good no explanations of the rule around to the 6th decimal point, which seems rather when a computer is working and the result of experiment loses its statistical significance. So I think if you are a mathematician, this should not be such things should not be neglected. My third comment is a global, maybe editorial comments in some 1.3 and 1.4.4. The global minimum maximum is always local minimum maximum. And finally, if we had a good list of definitions and terms, that would help. For example, you introduce definition INT. What does it mean? Yes. And of course, it means interior, but I think it should be explained to the new readers. But of course, my comments do not reduce the overall high impression. And because of that, let me say that the thesis by Majid Elkhan, Abbasov on the exhausting coexhausters in non-differentiated optimization meets the basic requirements established by the order, the 1st of September 2016, number 6821/1, on the order of academic awarding degrees of St. Petersburg State University, and the candidate, Abbasov Majid Elkhan, deserves to be awarded the degree of Doctor of Physical and Mathematical Sciences, Specialization 010109, Discrete Mathematics and Cybernetics. Clause 11 of the above-mentioned order has not been violated by the candidate. Thank you. no? Dr. Antipin. Dear colleagues, the whole world today is working on non-smooth problems in Europe, Asia, America. So the trend is very strong, which means well, the problem is very relevant. This, key results. The orthogonal extremum conditions and aggregated exhausters compares quasi-exhausters and co-differentials to solving tasks of non-differential optimization, describes the condition of minimality of exhausters and the technique of reducing families. Terms of exhausters and coexhausters, developed computation of coexhausters for subclasses, developed a method of minimization of the second order based on coexhausters. The need to study coexhausters is explained by the fact that it explains convergence of these computation processes, and the method of charged balls to solve auxiliary tasks is also very important. Non-differential optimization. So all the above mentioned results are new, as well as the approach which goes back to the works of Professor Demyanov, and especially nice that his students continued his work, and I can support this research, which is so different from other studies in this field. Theoretical and practical significance of the work lies in the fact that it makes a significant contribution to non-smooth analysis and non-differential optimization. And I also have some minor comments, which are quite typical in, for example, reference to conditions 129, 130 given page 8. In the rest of the text, the numbering of this expression is superfluous. The results of 0.19 can be somewhat simplified when defining the aggregate exhausters. And it was worth explaining the M parameter used to describe the heuristic algorithm in paragraph 3.1. Of course, these comments do not affect the overall positive impression of the thesis. And the thesis by Abbasov Majid Elkhan on the theme exhausters and coexhausters in non-differentiable optimization complies with the main requirements set forth by the order the 1st of September 2016, 68/21/1 on the order of awarding academic degrees at St. Petersburg University. And the applicant, Abbasov Majid Elkhan, deserves to be awarded the degree of Doctor of Physics and Mathematics with specialization 010109, Discrete mathematics and mathematical cybernetics. Clause 11 of the above-mentioned order has not been violated by the candidate. Member of the Dissertation Council, Dr. Antipin. Thank you. Vera Alexeyevna. I will not repeat what was said already mentioned by my colleagues. So I'll give a summary of my review. I think today Majid is a world leader in the computation of exhausters and coexhausters, and really, as was mentioned many times, these constructive things that can be expressed direction of ascent, descent. Here in Australia, these are very widely used, and Demyanov school is alive and functioning, and his approaches are very well used. I have a very good impression of their work, of the thesis, even though I read Majid's works before. I have worked in this field before. And not only these very interesting conditions of minimality, the method to reduce exhausters. I worked in this field, so this idea, I found this idea very interesting. And the study started by Professor Demyanov, the direction of descent, ascent. So the results are very impressive on a high professional level, and the results are very deep. A very interesting method of charged balls. This is a new method for design of sets, and in my opinion these methods are very relevant and very interesting today because of problems, large orders we get in from this field of data science. We're dealing with big data. We cannot use methods applicable to medium size with gradient descent methods. So the chargeable method is a very modern idea. So it would be nice to see it applied in other spheres, not only computation of exhausters. So basically, these are the advantages, the strong points. And of course, there are many other things that I could mention. Speaking of weaknesses or weak points of the thesis, first of all, in my opinion, there's enough description of the work of other researchers, not only of exhausters, but in other fields, and maybe in the future the popularity of exhausters will grow because of its interaction with other researchers, representation of functions, sets. But this does not affect, this is not a drawback of the thesis, because this is a very interesting paper and technically perfect. And in the end, I'd like to say that the thesis by Mr. Abbasov, exhausting coexhausters as non-differentiation, meets the basic requirements set out in the order of the 1st of September 2016, number 6821/1, on the order of awarding degrees at St. Petersburg University. And the candidate, Abbasov Majid Elkhan, fully deserves to be awarded the degree of Doctor of Science, Doctor of Physics and Mathematics, specialty 01010, Discrete Mathematics and Mathematical Cybernetics. Clause 11 of the above-mentioned order has not been violated by the candidate. Thank you. Thank you, Dr. Roshina. And now let me read my short review. In my feedback, I also mentioned relevance and problems with which the candidate had to deal, and this thesis, which describes these tools, the study, this work addresses relevant problems, and I also complement the novelty of the results. Let me list the results studied aggregated exhausters, proved the theorem of their existence, which is of constructive nature, compared application of exhausters and quasi-differentials for solving the problems on non-differentiable optimization. Describes the extremum conditions, suggested geometrical conditions of exhauster minimality and exhausting coexhausters, and the method of reducing these families. This developed computation of coexhausters of the second order. This developed a charged ball method, and also several heuristic probability algorithms. And while these methods can be used for solving some important SAS, all these results been presented at national and international conferences and published by Russian and international peer-reviewed journals, including the first quartile QA, or impact factor, TCR. And of course I have some minor comments. I will not, maybe the author should pay more attention to scientific overview, expanding the corresponding part. Since there's no universal definition of quasi-differentials in the terms of calculating, this is more, as this comment refers mostly to style. Paragraph 1.4, the phrase "the function of quasi-differential at a point," it should be replaced by "the function is quasi-differentiated at a point and allows quasi-differentials of the form of formula." For example, a smooth function can have non-smooth differentials, in a sense that differentials, the text would have been slightly reduced by going into detail only under the minimum conditions in terms of exhausters and coexhausters, explaining that the maximum conditions could be obtained in the same way, same manner. There are some misprints and several punctuation issues, yet these remarks do not affect the value of the study. The thesis makes a significant contribution, and on the basis of this, I believe that the thesis exhausters and coexhausters in non-differentiated optimization meets the basic requirements set forth by the order, or the set on the 1st of September 2016 by Order 6821/1, with order awarding academic degrees at St. Petersburg University. And its author, Abbasov Majid Elkhan, deserves to be awarded the degree of Doctor of Physics and Mathematics, Specialization 010109, Discrete Mathematics and Mathematical Cybernetics. Clause 11 of the above-mentioned order has not been violated by the candidate. Now, Dr. Abbasov, can you please answer? Thank you very much for your comments, for your feedback. Speaking of all editorial comments, I accept. There are some misprints and inaccuracies in my thesis, and in some cases the presentation could be improved. Some parts of my thesis are hard to read. I absolutely agree with this. Further, speaking of literature, I got several comments. The theory of constructive non-smooth analysis is mostly developed by the school of my teacher. That's why I paid so much attention. That's why the number of the works is so big. But I agree that I should have included more papers by my colleagues. And further, about the incorrect focuses on a connection of smooth and non-smooth cases. Of course, these facts can be derived by the reader from the text of the thesis, but well, this is important. These important points should be accentuated by the author. When the reader sees familiar structures and results, this makes his work much easier. Speaking of the curves, curves and chargeable method, the curvature. Indeed, well, the examples are illustrative, and I should give the necessary to give to explain to the reader how this algorithm works. In case of more complex curves, of course, we should be more careful in using the method. In that case, we shall get new tasks, but I think these tasks can also be solved in our future work. About aggregated exhausters and the requirement for closedness. Closedness, of course, could require, but our aim was to give a very general definition, which imposes minimum limitations, and that's why closedness was not defined here. But if there is a requirement that sets, including the family, are closed, that will make results simpler and shorter. Speaking of making the thesis shorter, if I only focused on the minimum, well, of course, yes, I chose this representation only for the convenience of the reader. So I could go straight to ready results. And speaking of rounding, when conducting our experiments, performing numerical experiments, each time all possible background processes capable with significant computational resources were disabled. But I agree that for the complete purity of the experiment, we need more precise settings. And the results obtained here in this sense, they are the estimates from above. But they already clearly demonstrate that the algorithm works very quickly. We talk about thousandths of a second. So even these estimations from the above, they fulfill their role. They show how quickly the algorithm works. And within the framework of this study, I think this is sufficient, but of course these results can be refined further. Speaking of the theorem for quasi differentials, the wordings will be more accurate because quasi differentials represented by formulas. These are only some possible ones, so we should be more accurate here. What else? I think I have answered all the comments. If I missed any of the comments, there are functions which are absolutely continuous. they are not absolutely continuous, non-continuous. For example, Gelder's function. So can you say a word on this? This is a very important theoretical issue. Today, in this thesis, I did not study this issue, and but you realize this is an important issue, and so your theory should say something about this. But so my plan is to do this in my future research. Thank you. Now it's time has come for we have the open discussion. Anyone who is not a member of the Dissertation Council may speak. And I know that Vasily Nikolaevich Malazorov would like to speak. Good afternoon. Vasily Nikolaevich Malazorov, Doctor of Physics, Department of Server Operation. Let me start by saying that since 2014, the constructive non-smooth analysis and optimization, and I'm the head of this seminar. And I'd like to say that Dr. Abbasov is a talented young scientist who's made some brilliant presentations, who works very fast. Speaking of his thesis and of his results, I would like to comment on points which impressed me most. The constructive non-smooth analysis. Let me explain why this is natural development. The main concept of nonlinear smooth analysis is the differential. Differentials are defined by single point, single gradient. The philosophy here is simple. Everything is linear. All classical mathematics originated from this concept. But there can be more complicated models where not everything is linear. Linear approximation is not very useful. A real breakthrough convex and maximum function. So this is also a non-smooth function, but this function is very real. It really occurs. And so we have to deal with these challenges somehow. So it all started with convex functions. Convex analysis derived from this point, and constructive non-smooth analysis, how this field developed. Since the key analysis was differential, how can this concept be generalized? The first generalization was about minimax problems, which was more easy, which were easier to understand, and we found that differential can be defined not as a linear formula, but as a maximum of linear formulas. And So we got a more generalized definition, which was applied to minimax problems, but which was not sufficient. I am describing this because I actually witnessed all these developments. Then the definition of quasi-differential was introduced. A quasi-differential is a difference of maximum of linear functions. That was a general definition. The appearance, but the matter as quasi-differentials worked with directions of descent, fastest descent. But at that time, the new methods developed, and delinearization. We introduced the concept of co-differentials, non-linear functions. So that was a real breakthrough, because many of the quasi-differentials was also applicable here. Two sets. Then but two sets, or in case of two sets or more sets, non-minimum or minimax or maximin, we needed a more general definition of differential. So then this new powerful quasi-differential. So that's how the non-smooth analysis is developing, and exhauster computations today is the highest stage of this research. So we could define these differentials, but also we need to calculate them. So what is this differential? Sum or a product? This class of new functions should include standard linear operations and maximin and minimax nonlinear operations. So it all worked perfectly well, these general classes of all operations. In this development, at some point, we ran into growth. In classical differential theory, first we got a set, then two sets, then many sets, and we lost singularity, what was very obvious before. Now it was not clear how to develop these computations. So that was a very challenging task, which requires complex operations with sets. And he dealt with geometry of exhausters, with operations of sets. This was very fine work, which in the end led this field of science to its present condition. And this work I attended Dr. Abbasov's defense when he presented his candidate's dissertation, candidate's thesis, and was very impressed. Next, as for application of his results, this is a very subtle issue. These are functions which have a subtle structure. We minimize these functions. What are these? These are very complicated. What are these such complicated functions for which is no smooth analysis is not enough? Of course, there are such functions. There are many methods. Of course, the contribution is we may speak of very significant contribution of Dr. Abbasov. So he brought this to a good state. As for application, of course, I have some doubt. I don't think that we will be able to solve some incredible tasks, but already we have tools. So creating this tool, completing these tools, I think is the main achievement of the candidate, and I think he deserves the degree of Doctor of Physics and Mathematics. General comments of the candidate. Thank you for this comment. Now let's stop broadcasting for 5 minutes. We need to have a discussion for this period of time. Please stop broadcasting, and all guests and colleagues who are not members of the Dissertation Council, please leave the room for that period, and we will invite you to come back after the discussion is over. So not everyone who is not a member of the Dissertation Council. Well, let's resume our meeting. I now put the awarding of the academic degree to the open individual vote. Let me remind you that the decision of the Dissertation Council shall be considered positive if more than a half, but not less than 3 members of the Council taking part in the meeting voted for it in accordance with Article 23 of the procedure for awarding academic degrees at St. Petersburg University, Annex 1 to the order. Well, please give your opinion. Dr. Zakharov, Viktor Vasilyevich. I believe the candidate deserves the degree. Afanasy Alexander Petrovich deserves. Alexander Valeryevich Bukhanovsky deserves the degree. Roshina Vera Alexeyevna, yes, deserves the degree. Antip Anatoly Sergeyevich, your opinion? Yes, I think our candidate is able to continue this is important field of research. So everyone has voted for, and I also believe that the candidate deserves the degree. So I am voting for. Thus, dear colleagues and guests, out of 6 members of the board participating in the meeting, 6 voted for, no one voted against, and no one abstained. Their decision to award the degree of Doctor of Physics in Mathematics, Specialization 010109, Discrete Mathematics and Mathematical Cybernetics to Abbasov Majid Elkhan has been taken. Let's give the floor to the applicant, the candidate, for his final word. Thank you. First of all, I'd like to thank all the members of the Dissertation Council for giving their time for their valuable comments, which will enable me to improve my work, for the comments that I will use in my future research. I would also like to thank the Dean of our faculty for his support, moral support. I'd like to thank members of our department of mathematical theory of modeling of management systems, Vasily Nikolaevich Malazemov. Most of the results presented here were presented at his seminar, which was started by Professor Demyanov Malazorov. The seminar is still functioning. I think these my speeches enriched my work, and the our discussions were also very helpful and very useful. Discussion at these seminars. I would also like to thank my academic supervisor, Vladimir Fedorovich Demyanov, who is not with us anymore, to our deepest regret, who opened my road to, and I would like to thank my father, because my father developed the love for mathematics, which I still love. And thank you. Thank you, everyone who for taking part in this session. The session is closed. Thank you all for your participation. Please stop online broadcasting. Thank you.